Welcome back, everyone. We're going to be solving LeetCode 74, search a 2D matrix. And this is essentially the same question as search a 2D matrix 2, except this question gives us a time constraint, right? We must solve this question using an algorithm that runs in log of m times n time complexity, whereas the second question to this question didn't give us any time constraints. So we could just solve it in n log n, right? Which is just running binary search on every single row within our grid until we find the target. So in order to get this runtime, what we have to do is run binary search on the columns to find out what column and then what row we need to run binary search on. So we'll run binary search on this first column, right? And then we'll find out that, oh, hey, our target is in the first row. So then we'll run binary search on the first row only, and that'll give us a time complexity of log of m times n. So let's do this. Left and right are going to be equal to 0, and the length of the matrix minus 1. While left is less than or equal to right, we will calculate our midpoint to be left plus right minus left divided by 2. Now we will say if the matrix at our midpoint 0, row, whatever our midpoint is at the first column, if that is equal to our target, we will return true. Else if our matrix at whatever row, position 0, column 0, if that is less than our target, we know we have to move our left pointer up by 1. So we'll say left is going to be equal to mid plus 1. Else we will say right is going to be equal to mid minus 1. Now, if we ever exit this, right, and this conditional never returned true, right, we know our value is going to lie within the right, the row where the right pointer is pointing at. So we can set our row to search equal to our right pointer, and let's print out our right pointer just so we can see where it's at. So in the case of example 1, right, our right pointer is at 0. Why? Because left starts at 0, right starts at 2, our midpoint is 10. We know our midpoint is greater than our target, so we're going to move our right pointer below the midpoint by 1, right? So now our right pointer is at position 0. This loop is going to exit, and this is what we will be left with, right? Our right pointer at position 0. So we know that's the row we need to search. Now we can just reset our pointers, left and right equal to 0, and then the length of our row this time, matrix of 0 minus 1, and then just run binary search on that row. So while left is less than or equal to right, recalculate our midpoint to be left plus right minus left, divide by 2. We will say if the matrix in our row to search at our midpoint, if that is equal to our target, we can return true. Else if the matrix at our row to search of our midpoint, if that is less than our target, we know we have to move our left pointer ahead of our midpoint by 1. Otherwise, we will just move our right pointer below our midpoint by 1, and then if we never return true, right, then we can just do a latent return false because we never found the target. So let's go ahead and run this. Perfect, we passed both test cases. So we'll submit, and it does run. Awesome. So time complexity obviously is going to be O of log m times n. That's what they wanted us to solve it in. And the space complexity is going to be O of 1. We're not creating any new data structures in order to solve this problem. All right, that'll do it for LeetCode 74.